One of the mysteries of Britain's ancient Stonehenge.
Unknown civilization living right here of Bronze Age people.
Stonehenge.
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 Stonehenge. Myth and legend have always surrounded its origins. It's been called both a healing site and a place of human sacrifice.
For more than 4,000 years, Stonehenge has stood on the Salisbury Plain, silent beneath the changing skies of Britain. Generation after generation has looked at those enormous stones and asked the same question. Why were they built? Was Stonehenge a sacred temple, a place for ceremonies, a burial ground, an astronomical calendar? Or was it designed for a purpose we have not yet fully understood? For centuries, archaeologists have studied the monument from every possible angle. They have measured the stones, examined the landscape, traced the origins of the rocks, and tried to reconstruct the lives of the people who built it. But now, a new kind of technology is changing the way researchers can investigate ancient monuments. Instead of looking at Stonehenge stone by stone, modern scanning technology can capture the entire structure as a three-dimensional environment. Every surface, every curve, every depression, every surviving tool mark. And when enormous amounts of archaeological data are combined with advanced computer analysis, patterns can emerge that are almost impossible for a human researcher to see on their own. That is where the real mystery begins. Because according to the scenario explored in this investigation, the digital reconstruction of Stonehenge raises an unsettling possibility. The builders may have understood far more about geometry, astronomy, sound, and construction than we usually imagine when we picture prehistoric Britain. And the strangest part is not simply how impressive the monument was. It is the possibility that some of its most sophisticated features appeared extremely early in its construction history. In other words, the people who built the earliest monumental sections may have already possessed knowledge that later generations struggled to reproduce. To understand why that matters, we first have to look at the stones themselves. Stonehenge was not created from a single type of rock. The enormous sarsen stones came from the Marlborough Downs, roughly 25 miles away. Then there are the smaller blue stones, many of which originated in Wales, hundreds of miles from the monument. Imagine standing on Salisbury Plain more than 4,000 years ago. There are no steel cranes, no trucks, no engines, no modern roads. There is no written engineering manual explaining how to raise a 25-ton stone into position. Yet somehow, these enormous blocks were transported, shaped, positioned, and assembled into a monument that has survived thousands of years. The obvious explanation is human labor. And there is no reason to doubt that prehistoric people were capable of extraordinary physical achievements. They could use timber, rope, stone tools, sledges, levers, earthworks, and enormous amounts of coordinated labor. But the deeper question is not simply how they moved the stones. It is how precisely they were able to shape and connect them. Stonehenge contains something remarkable. Some of the stones were fitted together using joints that resemble techniques we normally associate with later monumental architecture. Certain lintels were shaped to connect with upright stones. The surfaces were modified, the edges were carefully worked, and the stones were arranged into a structure where individual pieces depended upon the position of others. When modern three-dimensional scanning is applied to such surfaces, tiny irregularities become measurable. A human eye might look at a massive stone and see nothing more than rough prehistoric workmanship. A high-resolution digital model can tell a different story. It can compare thousands of points across a surface and determine whether a curve is random, deliberate, or repeated. That distinction is incredibly important, because if a prehistoric builder repeatedly produced similar curves and joints across enormous blocks of stone, then the question becomes, how? Were they simply extraordinarily skilled craftsmen? Did they use wooden templates, ropes, measuring systems, repeated geometric constructions? Or was there some practical technique that has simply disappeared from the archaeological record? This is where artificial intelligence becomes interesting. AI does not magically know how Stonehenge was constructed. It cannot travel backward in time. What it can do is examine enormous data sets and identify relationships that humans might overlook. Give an algorithm enough measurements from stone surfaces, positions, orientations, tool marks, and surrounding features, and it can search for recurring patterns. And one of the most fascinating patterns concerns geometry. Stonehenge is filled with circles, rectangles, axes, alignments, and carefully positioned stones. Some of these relationships can be explained through simple construction techniques. For example, a rope tied to a stake can produce a circle. A straight line can establish an alignment. Basic ratios can emerge from practical measurement. None of this requires a prehistoric mathematician writing equations on a tablet. But when several geometric relationships appear together, the interpretation becomes more complicated. The famous horseshoe arrangement of the Saracens was not simply a pile of rocks. The monument had structure. It had symmetry. It had repeated spacing. And it had carefully established lines of sight. That becomes even more intriguing when the sky is added to the equation. Stonehenge is famously associated with the movements of the sun. During the summer solstice, the rising sun aligns with the monument in a way that has fascinated observers for centuries. That alignment is not controversial. The real debate concerns how much astronomical knowledge the builders actually possessed. Did they deliberately construct Stonehenge around solar movements? Or did the alignment emerge naturally from the way the monument was oriented? The evidence suggests that the relationship with the sun was important. But researchers have also examined lunar movements. And this is where the mystery becomes much deeper. The moon does not follow the same simple annual pattern as the sun. Its position changes gradually over time, and one important cycle associated with its extreme positions lasts approximately 18.5 years. That means recognizing the full pattern requires long-term observation. Not a single night, not a single season, years and decades. If prehistoric observers deliberately incorporated this cycle into the monument, then they would have needed a sustained tradition of astronomical observation. Someone would have needed a watch. Someone would have needed to remember. Someone would have needed to pass the information to the next generation. And that raises a fascinating possibility. Perhaps Stonehenge was not built by one generation at all. Perhaps it was the physical result of knowledge accumulated across many generations. A monument that functioned as a kind of memory system. Instead of writing astronomical information on paper, the builders encoded important relationships into stone. The sky changed. People died. Communities moved. Languages disappeared. But the stones remained. And then there's another feature that researchers have increasingly found fascinating. Sound. Stonehenge looks impressive from the outside, but the experience of standing inside the original circle would have been very different from what visitors experience today. Thousands of years ago, when the stones were complete, sound would have interacted with the massive blocks surrounding the interior. Voices could reflect from stone surfaces. Drums could reverberate. Chanting could become more intense. Certain frequencies could behave differently from others. Modern acoustic modeling can recreate these possibilities. And the results suggest that the stone arrangement could have produced noticeable acoustic effects. This does not automatically prove that Stonehenge was deliberately engineered as a giant sound chamber. Circular stone structures naturally affect sound, but the possibility is intriguing. Imagine entering the center of Stonehenge during a ceremony. The outside world is separated from you by enormous stones. A drum begins beating. A voice begins chanting. Instead of simply hearing the sound directly, you hear reflections returning from the surrounding megaliths. The sound becomes larger, deeper, more difficult to locate. For people living thousands of years ago, without modern acoustics or electronic amplification, such an environment could have seemed extraordinary. And if the builders understood how the spacing and shape of the stones affected sound, then Stonehenge may have been designed not only to be seen, but experienced. Yet the acoustic question leads to something even more important. How much planning was required to make all of these features work together? Because Stonehenge was not simply a collection of stones placed randomly across a field. The monument changed over time. Earthworks appeared. Holes were dug. Stones were transported. Some stones were rearranged. Others were added. Paths and surrounding features became part of the landscape. This means Stonehenge was not a single construction project completed in one moment. It was a process, a tradition, a monument that evolved across centuries, and that creates one of the greatest mysteries surrounding the site. If knowledge was being developed gradually, then we should expect later builders to become more sophisticated. They should learn from earlier mistakes. Their techniques should improve. Their construction should become more efficient. But what if the opposite happened? What if some of the earliest monumental work was actually among the most precise? That possibility completely changes the story. Instead of imagining primitive people slowly discovering monumental engineering, we would have to consider a different model. Perhaps the builders inherited techniques that had already been developed somewhere else. Perhaps the knowledge came from an older tradition. Or perhaps we were simply underestimating what prehistoric communities could accomplish when they had generations of experience, enormous motivation, and thousands of people working toward the same goal. There is still another mystery: the stones themselves. Some of the blue stones were transported over extraordinary distances. Their geological origins have allowed researchers to trace them back toward Wales. But why those particular stones? Why make such an enormous effort to move rocks from distant landscapes when suitable stone existed much closer? One possibility is symbolism. The stones may have been connected to ancestral places. They may have carried cultural meaning. Another possibility is that the builders valued physical properties of certain rocks. Some blue stones can produce unusual sounds when struck. To modern ears, they can almost behave like stone bells. If sound was important at Stonehenge, that becomes an intriguing detail. Perhaps certain stones were selected because they sounded different. Perhaps their meaning was not purely visual. But there is an even bigger question. What existed beneath the ground? Stonehenge is only the visible portion of a much larger archaeological landscape. The surrounding area contains burial mounds, earthworks, pits, pathways, and other ancient structures. For decades, archaeologists have used non-invasive techniques to investigate what lies beneath the surface. Ground-penetrating radar can detect buried anomalies. LiDAR can reveal subtle changes in terrain. Aerial photography can expose patterns that disappear when viewed from ground level. And three-dimensional mapping allows researchers to combine all of these datasets into a single digital landscape. The result is a completely different way of looking at Stonehenge. Instead of seeing one circle of stones, researchers can see a network of ancient activity stretching across the surrounding countryside. And that raises a possibility that may be more important than any single stone. Stonehenge may never have been intended to stand alone. It may have been the centerpiece of a much larger system, a ceremonial landscape, an astronomical landscape, a place where architecture, landscape, movement, sound, and the sky were all connected. If that is true, then the real Stonehenge mystery is not hidden inside one stone. It is hidden in the relationship between thousands of individual features. And that is exactly the kind of problem modern computational analysis is good at exploring. But just when the digital evidence begins to make the monument look more sophisticated than expected, another question emerges. If these people possessed such knowledge, where did it come from? And why does so much of it seem to disappear? Because one of the strangest possibilities surrounding Stonehenge is not that ancient people somehow knew too little. It is that they may have known much more than we realize, and that some of that knowledge may have vanished long before history had a chance to record it. And if that is true, then the stones we see today may not represent the beginning of a technological tradition. They may represent what was left after that tradition had already begun to disappear. But there is one discovery that makes this possibility even more disturbing. A pattern hidden not in the shape of the stones, but in the timeline of how Stonehenge itself was built. And when that timeline is reconstructed, the story of human progress at the monument appears to run in the wrong direction. The best may have come first, and what happened afterward could completely change the way we understand the people who built Stonehenge. But the deeper researchers looked into Stonehenge, the stranger the story became. The monument was not simply a circle of giant stones standing alone on Salisbury Plain. Beneath and around, it was a much larger prehistoric landscape filled with pits, earthworks, pathways, burial sites, and other mysterious features. Modern scanning technology allows researchers to examine this landscape without digging everything up. Ground-penetrating radar, aerial mapping, LiDAR, and high-resolution 3D models can reveal subtle patterns hidden beneath the ground. And these patterns suggest that Stonehenge may have been part of something much larger. The monument appears to have been designed around movement, visibility, and celestial events. People approaching the site would have passed through carefully arranged areas before reaching the stone circle itself. Inside, the experience may have been even more dramatic. The enormous stones could reflect and alter sound, creating powerful echoes and reverberations. Voices, drums, and chanting may have sounded completely different inside the completed monument. If that acoustic effect was intentional, Stonehenge may have been designed to create an experience that was both visual and auditory. But perhaps the most fascinating possibility involves astronomy. The monument clearly has a relationship with the sun, especially around the summer solstice. Yet researchers have also investigated possible connections with longer lunar cycles. The moon's extreme positions follow a cycle lasting roughly 18.5 years. Recognizing such a pattern would require observations across many years. If the builders deliberately incorporated this cycle into Stonehenge, they were not simply watching the sky. They were preserving astronomical knowledge. And that may explain why the monument survived for so many generations. Stonehenge could have acted as a physical memory system. Instead of writing information in books, its builders encoded important relationships into stone. The positions of the stones could mark directions. The openings could frame celestial events. The surrounding landscape could guide movement. And the entire monument could preserve knowledge long after the people who created it were gone. But there is another mystery. Why did the sophistication of the monument appear so early? If prehistoric builders were gradually learning monumental construction, we might expect later generations to become better. Instead, some of the earliest work appears remarkably sophisticated. This creates the possibility that the builders were not starting from nothing. They may have inherited knowledge from earlier traditions that we have not yet discovered. Or perhaps the truth is simpler. Ancient communities may have been far more capable than the modern stereotype of primitive humans suggests. They could organize enormous workforces, transport massive stones, observe the sky for generations, and transform their understanding of the world into architecture. And that may be the real shock hidden inside Stonehenge. Not that its builders possessed impossible technology, but that they possessed knowledge we have underestimated for centuries. The stones are still standing. The people who built them are gone. Their language is gone. Their explanations are gone. But their measurements remain. Their alignments remain. Their monument remains. And now, modern technology is giving us the ability to examine details that human eyes could never fully see. Every scan adds another piece to the puzzle. Yet the final answer may remain frustratingly out of reach. Perhaps Stonehenge was an astronomical instrument. Perhaps it was a ceremonial center. Perhaps it was a monument to ancestors. Perhaps it combined all three. What we do know is that its builders were capable of thinking far beyond a single lifetime. They created something designed to survive them, something that could preserve knowledge long after the original builders disappeared. And after more than 4,000 years, Stonehenge is still doing exactly that. It is still standing, still watching the sky, and still challenging us to understand the people who placed those enormous stones there. Maybe the greatest mystery is not what Stonehenge hides. Maybe it is what the people who built it already knew.